Welcome to Internet Infrastructure Explained.
Have you ever made a change to your website or updated a domain name system record, and then wondered why it seems to take different amounts of time for everyone to see that change? It is a common experience, and it points directly to an essential concept in Internet infrastructure. Yes, DNS caching absolutely impacts propagation delays. While DNS propagation refers to the time it takes for a record update to spread across the global network, caching determines how quickly individual users or systems actually see that update, often making delays feel much shorter or, in some cases, longer than the raw propagation time. The core mechanism here involves understanding both DNS propagation and DNS caching. DNS propagation is the process where a change made on an authoritative name server, like updating an IP address for a website, is gradually replicated to all other DNS servers around the world. This can take anywhere from minutes to several hours. Meanwhile, DNS caching is the temporary storage of DNS query results by various components in the network path, including your web browser, operating system, router, and your internet service provider's DNS servers. When a system needs to resolve a domain name, it first checks its cache. If the record is found and is still valid according to its time to live, or TTL value, it uses that cached record instead of querying the authoritative server, effectively bypassing the real-time propagation. This means that even if a new record has propagated to a distant server, your local system might still be serving an old, cached version until its TTL expires. Conversely, if you are the first to query a newly propagated record after your cache is clear, you will see the update immediately. For administrators, setting an appropriate TTL value on DNS records is crucial. A shorter TTL means changes propagate faster but also results in more DNS queries. A longer TTL reduces query load but means updates take longer to reflected for users relying on cached data. Beyond just simple record storage, DNS resolvers often employ techniques like negative caching. This is where a resolver remembers that a particular domain or record does not exist * for a certain period, preventing repeated lookups for non-existent entries and further optimizing network traffic. Another advanced concept is DNS prefetching, where browsers proactively resolve DNS entries for links on a page before you even click them, significantly speeding up perceived load times when you navigate. Understanding DNS caching and its interplay with propagation delays is key to managing user experience and network efficiency. By strategically setting TTL values and appreciating the layers of caching, you can optimize for both rapid updates when needed and reduced latency for stable resources, ensuring a smoother, faster, and more reliable internet experience for everyone.
If you love understanding how the web works, like, subscribe, and stay connected with us.